Hello and welcome to 5-Minute Math. Today we are looking at the lessons learned from the 8th grade STAAR test 2023. My name is Aaron Daffer and we will be looking specifically at our readiness standards that we had less than 50% accuracy across the state of Texas. So these 6 standards will be what we are looking at. Not only why did students struggle, but what are the instructional implications. So let's start with this first one right here. And so 8.8C is actually the most difficult. You saw we had 32% mastery. Overall, we had to model and solve one variable equations with variables on both sides. Right? So we had to use the properties of operations to solve for and isolate a variable. So number 10 had 39% correct. Here we had algebra tiles. So what we had to set up for was negative 3x plus 4 equals negative 2x plus 1, right? But then we had to solve for x, but what some of our students probably did is we might have, just added 2x to each side here, and that's just going to get us, negative x plus 4 equals 1, and then if we subtract 4, that's going to get us negative x equals negative 3, simply because we're used to the x being on the left side. And you see that negative 3 is one of the answers, and actually it was chosen by students 30% of the time, whereas the correct answer is this positive 3, because we had to multiply by negative 1 or divide by negative 1 because we don't want an x to be negative. So that was a challenge for students there. And then this problem, 36, is very innocent looking. Seemed very difficult. Jessica baked 72 cookies, sold X. Max baked 36, sold half as many as Jessica, so Jessica sold X. They each had the same amount of money, so we're solving for X. But look what happens if I add, this plus X to both sides. 36 plus, that's a 1/2 X. So even if I subtract 36 here, that's going to get me 36 equals 1/2 X. You see how that's difficult? 36 obviously is one of the answer choices, and it was actually chosen by students 23% of the time. So a good chunk of them chose that. The correct answer here is the 72 because you had to multiply both sides by 2, but that was difficult for students. So let's look at the instructional implications. What does this mean for our students? Well, we need to model and solve these one variable equations, but not just in a vacuum, right? Algebra tiles are going to be very important for our students to work with. That made it a little bit more difficult for our students using the visual representation, and doing it from a verbal description was a little bit harder than we would expect. So we had challenges with the visual representation, we had challenges with the verbal description, and then we saw here on that second problem, and included a fraction as one of the coefficients. If they did what they were supposed to, you were going to get this 36 equals 1/2 X. And the question is, what do you do with it then? So what does that mean for us? Well, we need to continue to practice using algebra tiles, verbal descriptions. That's going to be so much more valuable than simply doing it with raw numbers, right? So we could solve for this, even though this is a little bit tricky with that 1/2 X. But getting that from a real world problem and then creating the equation, having it not given to you, that requires a lot more thinking. And then we need to specifically call this out. What do we do when X is one of the coefficients is a fraction or negative, right? Let's call that back out. What happens when you have a negative X equals negative 3, right? That was in the first one. And do we know enough to say we're not supposed to end up with a negative X? We need to multiply or divide by negative 1. So our next most difficult readiness standard was 8.5I. We only had 33% overall mastery. We need to write an equation in the form y equals mx plus p, our slope-intercept form. Now here's the issue, is we are given 2 points here, and on this second one, number 29, we're not even given anything, we're just given a graph. So this is challenging simply because it takes quite a bit of work, and the more work it requires, the more opportunities there are for students to make careless mistakes. So how would we solve this one? Well, we could graph this if we needed to, but really we don't, right? We first need to find our slope, right? So let's make this our x sub 1, y sub 1, our x sub 2, y sub 2, and let's apply our formula for slope, right? Negative 50 minus 70 over 6 minus negative 2. And what you're going to get is negative 120 over 8. So that's going to be negative 15, right? So if we wanted to, we could have put those 2 points up here on the grid like this, and 6 and negative 50, but we really don't necessarily need to. All that's going to tell us is, well, we've got a negative slope. Well, that's what that is. So now we need the y-intercept. So we need to plug in one of these points. Doesn't matter which one. Let's plug in that one. So let's plug in negative 50 equals negative 15, and then our 6 plus b. That's the y equals mx plus b. And I substituted in my y and my x from the 650, and then my negative 15 I just found. And we just need to solve for that, right? So that's going to be negative 50 equals negative 90 plus b, and then we add 90 to both sides. We get 40. B equals 40. So it's going to be this y equals negative 15x plus 40, right? So that's that d. But you see how much work that required. I had to first find the slope, then I had to plug in the points, and then find the y-intercept. And at least I had A, B, C, or D to choose from. We don't have that over here on number 29. You saw we only had 30% of our students get full credit, and 33 get that partial credit, which means they just got one of these correct. And we visually have to plot these. Now we do have some intercepts here, right? So we've got a y-intercept, we've got an x-intercept. We could do that same thing, right? We're just going to take it x sub 1, y sub 1. Doesn't really matter which one you do, right? So we're going to do 0 minus 6 over negative 4 minus 0, right? So that's going to be negative 6 over 4. So that's going to be 3 halves, right? Because that's a negative as well. Excuse me. And so that goes here. And then we need to find the y-intercept. Now that's a little bit easier because they gave us the y-intercept. If you visually look at it, it's that 6. So it's that 6 right there. So that one we should have done a little bit better. And if you count this partial credit as, part of the work, we maybe get 63% of our students that get at least 1 point out of a 2-point question. But what does this mean for us in our instruction? Well, students were challenged here because we had to find the slope-intercept form. Given 2 points, they were only given a graph, and so the drag and drop partially removed partial guesses, any type of certainty. The first problem, you at least had A, B, C, or D to choose from. That drag and drop makes it a little bit more difficult. So this is what made it difficult for our students. We just need to practice converting between forms, right? So first off, we need to practice how do we find slope-intercept form, right? But how do you take 2 points or a table, and how do you turn that into a graph, right? How do we take 2 points or a table and turn that into slope-intercept form? So that's what we did, with one of those problems, that first one. They gave us those 2 points. Even though they gave us the graph, we didn't need the graph. So how do you take a graph, turn it into slope-intercept form? That was the second problem, right? Just a graph, visually take a look at it. But how do you take a graph and turn it into 2 points or a table? How do you take the slope-intercept form, turn it into a graph? How do you take the slope-intercept form, take it to 2 points or a table? There's different ways that we could be viewing our slope-intercept form, right? Using verbal, numerical, tabular, or graphical representations. And we need to get our students practicing going between each of them rather than always trying to just graph something or always trying to just find the slope-intercept form, because we need to get them flexible using multiple representations of y equals mx plus b. So we only had 34% overall mastery for 8.4c. This is determining the rate of change or the slope, right? And the y-intercept. So whether you want to call it the rate of change or the slope and the y-intercept. So take a look at number 24. This was difficult because we had the equation editor, right? The slope is the challenge here. The y-intercept, visually we can see, all right, it's going to be 0, -2. A little bit of a challenge. We wanted to make sure that the students grabbed, that negative button, which is next to the decimal. It's right underneath the 0, but it doesn't look that different. So maybe a student might have misclicked on that. But the slope here was a challenge, right? Because if we take our x sub 1, y sub 1, x sub 2, y sub 2, right? So it's going to be -1 minus that -3. Then it's going to be 4 minus that -4, right? What do we get here? We're going to get 2, right? And then we're going to get that 8, right? So 2/8. So you had options. You could have put in 2/8 if you want to. You could have simplified it, 1/4. You also could have put in the decimal. But putting in a fraction is a little bit tricky on the equation editor because you have to hit that fraction button first, and then it pops up, and you have to type in the numerator. Then you have to click down here, a little gray box shows up, and then you click and you type in the denominator. So it's not as intuitive as you would want. So you have to click that fraction button first, or it would have accepted it if it was that 0.25 if you wanted to put a decimal as well. Now over here on number 32, we only got 40% correct. We had to find our slope here, right? So our slope, you see that this is a +2, right? And that's a +60, right? So it looks like it's a change of 30 for each one. And then what we had to do is we kind of had to go backwards, right? We had to go backwards. So if that's another +2, we're going to take 60 away from that, and that is going to be 165. Then we need to do another +2 to get down to 1, right? So that's going to be 105, and then another 1 to get to that 0, right? To get to that 75, we had to work backwards because we had to figure out the initial amount was 75. We had to realize that was our y-intercept. So not only did we have to find the slope, we had to interpret it and then work backwards. So that definitely was a challenge. So what does this mean for our instruction? So the equation editor definitely removed the comfort of multiple choice options. It made it a lot more difficult, so we need a lot of practice with that. And then we had to enter a fraction or decimal for the slope. Once again, that was difficult on the equation editor. And this -2 on the y-intercept, it might seem very easy, but I would assume that some students probably just entered in a 2 just for getting the negative. And then this definitely was difficult on the second problem, having to derive the slope and then work backwards to find the starting position, the y-intercept, and then even recognizing that the starting position was the y-intercept because that came from a word problem. So how do we help our students with this? So we definitely need more opportunities for the equation editor, especially fractions, mixed numbers, and I'll even add decimals to that. Adding numbers, single digits, two-digit numbers are pretty easy, but we need to give them opportunities to practice with fractions and mixed numbers. And then this was difficult, finding the y-intercept of a linear equation from data in a table when it starts like on, step 5 or step 7. Having them work backwards when you had to first derive the slope from like 2 steps here and then take that down to a single step and then work backwards. That is a challenge for students when they have to find this right over multiple steps and then find the actual rate of change and then work backwards. For 8.75b, we only had 39% overall mastery, and that we're looking for a surface area, right? So both of these looked for total surface area, so we didn't necessarily have to find the difference or find that the correct equation between lateral surface area, total surface area. Now, what made number 25 so difficult here was they didn't give you a visual, and it would have been very helpful to draw a visual, because trying to just figure this out without it, right? Let's just see what we have here. I've got an 8 and I've got a 16, and I know I'm supposed to multiply stuff. So if I multiply 8 and I multiply 16, right, I am going to get this 128, and this was actually the most chosen answer. This was chosen more than the actual correct answer because students probably just eyeballed it and just multiplied two things, and 128 shows up. What we actually have to do here is we have to draw a representation, right? And we see that we've got a height of 8, but they only give us the area. The area is 16. So if I'm going to, find my perimeter in terms of height, right? And then I'm going to double the base and add those two together. Well, I've got to derive the perimeter from this because they only give me the area. So that's a challenge. You could do it, but it requires you to do a little bit of thinking to find the perimeter. Then you just double the base. So that's what made number 25 correct, is there was no visual. And 8 times 16 was low-hanging fruit. It was chosen more than the correct answer here of 160. As you can see on number 6, we've got visuals all over the place. This just requires a whole lot of calculation. You not only have to calculate the correct answer from up here, right, but then you have to find one that matches, and if they did in order, it's all the way down at the very end. So that's just a lot of calculation, which means a lot of room for error, or possibly just kind of getting over it and just guessing. So what does this mean? Well, students had to perform multiple calculations and track them to find the correct answer, especially with that second one. You had to keep track of so many different calculations. This oversimplified option for that first example was used more than the correct formula, right? So we need to make sure that students recognize the difference between total surface area and volume, and all the needed measurements were not explicitly provided, right? We had to derive the perimeter from that first example because they only gave us the base. So how do we help students with this? Well, we need to have students practice problems in the format of number 6 to build stamina, right? And that is going to be our second one right here, where it's just a whole lot of calculations. And it's plain and it's in front of you, but can you stick with it long enough? And the second one, that was with the first example here, of how do we calculate the total surface area when you have to derive one of the dimensions. They don't necessarily give you the perimeter and the height or the length and the width. They might give you the area, and you have to figure out what the perimeter is from there. So that would help students be a little bit more comfortable when those problems arise in the future again. So 8.7a, we had 41% overall mastery, but really the issue is this number 14. So we see we have a cylinder here, right? And we need to find the volume of that, right? So that's volume equals base times height. And here's the issue. If you just find the volume of the cylinder, that's going to be B, and that's the actual most chosen answer, but that's incorrect, obviously, because it doesn't have anything to do with this hemisphere that's up on the top, right? So we need this right here. Volume equals that 4/3 pi r cubed, right? That's how we find the volume of a sphere. But since that's half of a sphere, we need to divide that by 2 or cut it in half. Or maybe, have that 2/3 rather than 4/3. There's a few different options there. And that would get us our correct answer of C if we added those two together. But students here had difficulty with that hemisphere, so a lot of them just did base times height, and they found B. We have the volume of a cone over here, and this one we didn't do nearly as bad. The only issue that tripped us up here, we got the correct answer here. You see it's a little bit higher for B. That's because some students did the slant height, right? So we're doing 1/3 base times height, but the question is, what is the height? This is the height right here, but some students use this slant height as the height for the formula, and they got a slightly higher answer, B. So what does this mean? Well, let's look at the analysis of the problem. First, the very first problem, the one that had the cylinder and the hemisphere, look at our answer selections here, indicative of guessing. So that lets us know that students weren't really sure of how to deal with that composite shape, and they had to derive the formula for the volume of a hemisphere, because once again, all we have is that 4/3 pi r cubed. They had to figure out, well, you multiply the whole thing by 1/2, or maybe you divide the whole thing by 2, something to get the volume of half of a sphere or a hemisphere. That was challenging. And then that slant height, it was provided, but that was extraneous information. So what does that mean for our instruction? Well, we need to have students practice composite shapes and how to find the volume of a partial shape, like half of a cylinder, or half of a sphere, or a quarter of a sphere. We need to find the volume of composite shapes and partial shapes together, and adding those together using the additive property of volume. And then we need to have students practice with extraneous information, right? That's the slant height versus the actual height, and evaluating what is needed and what information is extra. Finally, our last reporting category that had less than 50% mastery is this 8.12D. We are calculating and comparing a simple and compound interest. And as you can see, we didn't do too bad on this first one right here, number 17, 64% correct. That's not fantastic, but for this test, it's actually pretty good. But you see, it's simple interest, right? So we get a little bit more complex on number 37. It is going to be compound interest rather than our simple interest, and it's drag and drop. So here's the thing. When we look at our compound interest, we see this A equals P, right? 1 plus the R to the T power. The problem with that is we had to find it twice for year 1, right? And then year 2. But this formula doesn't give us the interest. It gives us the new balance. So then we would have to subtract the principal in order to find what we needed. And that extra step, finding the new balance and then subtracting the principal, which leaves us with just the interest, might have been a challenge for some of our students. We see that only 28% got both of these items correct. Now, if you're wondering, this new balance was not one of the options. So if they got that, it was like 10,250 for this first one. That wasn't one of the options. So after that, I'm not sure if they knew what to do next. 29% got partial credits. You put those together, it's looking decent, over 50%, but it's still not what we need. So what are some of our instructional implications and analysis? Well, we need to take a look at what happens when we need to find just the interest, right? So that first problem was the simple interest, and that's what we get in regards to the formula. But when we need to find the interest on a compound interest, we have to subtract, right, what we calculate, and that's what I showed you right here. We need to subtract that principal to get the interest. So that was part of the challenge. And then that drag and drop always makes it a little bit trickier because you don't feel like you know whether you're right or wrong. There's so many options. So how can we help students improve? Well, we need to give students, given both a set of data, right, have students practice finding simple and compound interest over multiple time periods, right? So find the difference between simple interest and compound interest with the same data set. And then using, once again, the same data set, finding the new balances over multiple time periods. Like, so what's the new balance over 1 year, 3 years, 5 years? Because those are two different things. Finding interest and then finding the new balances. And so operating how to do one or the other or both. And then we need to have them verbally explain what is the difference between interest and the balance, and between simple and compound interest. Just being able to read a formula off the mathematics chart is not going to set them up for success. They need to be explain the difference between the interest and the balance, right? And then simple and compound interest as well.